So now another thing we need to know is the special angles. So let's start with angle 45. So angle 45 degree. To derive angle 45 degree, or because this is jam, we don't need to cram the derivation or anything. Okay, but let's say we have angle 45. Let's derive. So I will now show you a trick. So we use right angle triangle. So here is theta. So here is for angle 45. Here is 1 1. So we are going to find this place. If you want to derive 45, you use this setup. So now find this hypotenuse. So using Pythagoras theorem, hypotenuse square equals opposite square plus adjacent square. So that means the hypotenuse will be equals to s square equals 1 square plus 1 square. So s square equals 1 plus 1. S square equals 2. So s equals square root of 2. So that means this place is square root of 2. Now let us find sine 45. So this place I put theta. Yeah, it's 45. So yeah, here will be 45 degree because angle 45. Now what is sine 45 degree? So that is opposite, say where the angle is facing, opposite 1 over hypotenuse, that's root 2. So this 1 over root 2 is also, if you rationalize 1 over root 2 to be 1 over root 2 times root 2 over root 2. So this will be equals root 2 over 2. Why? Because 1 times root 2 is root 2. Then root 2 times root 2 is root 4, and which is 2. So that means sine 45 is also root 2 over 2. Please take note of this because JAMB will not give you trigonometric calculator. That is calculator that you can find sine, cos and tan. You won't have that. So you have to know these special angles. So that means sine 45 is 1 over root 2 or root 2 over 2. Then another one is cos 45 degree. So what's 45 cos? That is adjacent, and you know this is adjacent 1 over hypotenuse. That is SOHCAHTOA. So adjacent over hypotenuse, that is cos. So this is also 1 over root 2, which is the same thing again as root 2 over 2. Then tan 45. So tan 45 degree. That is opposite over adjacent. So that is 1 over 1. So that is 1. That is opposite 1 over adjacent 1. So 1 over 1 is 1. So take note of this. That is, let me create a table for this. So let's say we have sine let's say this is theta. So 30, 45, 60. So like this. So now sine 30, the one we did now is 45. So sine 45 is root 2 over 2. Cos 45 is also root 2 over 2. Tan 45 is 1. So we have done for 45 like that. So now let's do for 60 and 30. So to do for angle 60 and 30, so we are going to use equilateral triangle. So let's assume this is equilateral triangle. Equilateral triangle, all sides are equal, all the angles are equal. For equilateral triangle, the angles are 60 degrees each. And all the sides are equal. Here we are using 2 units. So if you divide this triangle into 2 equal parts, here will be 90. Then this will be divided into 1. That is, this 2 will now becomes 1. So you cut it into 2. That is 1. And these angles will also divide. That will be 30 degree, 30 degree. So take note that this part is just to derive the special angles. So in case you want to learn how we got them. So now this right angle triangle is 2. Just take one of it out. So just take one of it out. So this is 1, 60 degree, 30 degree. So here is 2. So we need to know this place. Let's call it X. So to find this place, that is opposite. As if you look at it this way, that is opposite. So but we use Pythagoras theorem because we know 2, we know 1. So we need to know that place. And what is Pythagoras theorem? Hypotenuse square equals opposite square plus adjacent square. So hypotenuse is where this 90 is facing. That's 2 square equals opposites. That's the s square plus adjacent square. That's 1 square. So here is hypotenuse, opposite, and adjacent. So take notes. So this will be 2 square, 4. S square plus 1 because 1 square is 1. Collect like terms. S square is 4 minus 1. S square is 3. So S is square root of 3. That means this place is square root of 3. So now let's form the angles. Remember, this is just derivation of it. I have to do it so you will know how we got those angles. Now let's do sine 30. So if you say sine 30, so it is where this 30 is facing that is your opposite. Then here is hypotenuse, here is adjacent because you are doing sine 30. So sine 30 now, that is opposite 1 over hypotenuse 2. So that means sine 30 is 1 over 2. Now cos 30. Cos is adjacent over hypotenuse. That is 1. Adjacent is here because this is 30. So this place and this place are the adjacent. So now adjacent, that is root 3 over hypotenuse, that's 2. That means cos 30 is root 3 over 2. Then tan 30, tan 30. So that is opposite over adjacent. That is 1 over root 3. So if you rationalize 1 over root 3, it will be times root 3 over root 3. So 1 times root 3, that is root 3. Then root 3 times root 3, that is root 9, and that's 3. So that means 1 over root 3 is also so 1 over root 3 is also root 3 over 3, like that. So that means tan 30 is root 3 over 3. So now let's move to 60. 60. So if you have 60, here is now opposite for 60 degree. So that means sine 60 is opposite, that is root 3 over hypotenuse. So that is root 3 over 2. Then cos 60, that is adjacent. Here is now the adjacent. So that is 1 over hypotenuse 2. So cos 60 is 1 over 2. Then tan 60, opposite over adjacent. So that is root 3 over 1. That is opposite over adjacent. So that is root 3 over 1, which is the same thing as root 3. So this place is root 3. Now you need to know this table often. So there is now another trick that you can use to learn the table without cramming or without cramming anything here. So just follow this procedure. So now let me set up the table again. So and learn the procedure. Sine theta 30 45 60. So write 1 2 3. Take note to cos 3 2 1. Take note of this trick. So if you don't want to follow all those patterns, then if you have this, you want to memorize this, write 1 2 3, then 3 2 1, like this. Now divide each by 2 over 2 over 2 over 2 over 2 over 2. Do you get the trick? Then put square roots on everything. That is the top. Put square root. So do you notice now that we got this result? Because root 1 is 1. So that means you got this result for this. Now for the third one, which is tan. So you can memorize this. So just say over 3 over 3 over 3. So root 3 3 and 3. So what I actually have here, let me show you very well what I'm doing. So over 3 over 3 over 3, like for the third one, this is what I have: 3 over 3, 3 over 3, 3 over 3. So put roots there. But know that this last one, so you just master this last one, that is over 1. So that if you put root 3 there, so that can give you over 1. I mean, sorry, there is what I want to explain here. So apart from these two, that 1 2 3 and 3 2 1, so just devise a way of getting this last one. So what I want to do is that I put 3 3 in everything first, but you have to know that it is only this first one that has roots. So that's what I want to explain, and this last one does not have over 3. So just take notes, like root 3, then 3 over 3 is 1. So if you can memorize this last one and know it's root 3 over 3, 1, then root 3, fine. But the first two, you have 1 2 3, 3 2 1. So divide by 2, divide each by 2, then put square roots. So you are going to get this and this straight. So just divide, remember this last one, so it can still help.